Welcome. This is Keeping Your Kubernetes Cluster Secure. My name is Gene Gotimer. How many of you were here for the previous session in this room? Anyone? Okay, there is going to be a little bit of overlap. He talked about what things you're supposed to be doing. I'm going to talk about some tools to help you do those same things. All right. So one of the things about keeping your Kubernetes cluster secure is there's a lot of different layers to Kubernetes. So what I'm going to do is I'm going to go through the different spots in Kubernetes, in your pipeline, in your process that you can use some tools. These are all going to be open source tools that can help you just improve security. Not going to make it perfectly secure. There's no such thing. But what I want to do is go through these different layers and give you an idea of the types of tools you can use. Now, I'm going to make some suggestions on tools. I can show some of the tools. It's really not all that important that you use these tools that I'm talking about. For one thing, I use open source tools not because they're free, but because it's a lot easier to bring them into the environments where I am. I'm a government contractor. I do most of my work for the federal government. Bringing in a commercial tool, the money is usually not a problem because it's your money. But it takes months, 6 months, 8 months, a year to bring in a tool. Whereas if it's open source, I can put it on a list as long as it's approved. I can have it running that afternoon, right? It's just much easier for acquisition. So nothing against the closed source tools, just harder to work with in my environment. And nothing against these open source tools. Many of these open source tools make up the commercial versions. They're the same pieces, just running in separate without a dashboard, without the RBAC, without authorization systems attached, that type of thing. So, all right. If you have any questions throughout this, please feel free to stop me as we go through it. We don't need to wait to the end for questions if you don't want to. All right. So we're going to look at 10 different tools across 3 rough layers, right? Just layers as I see them. There's nothing official about these. There's the infrastructure, which is really made up of the hosts and the clusters. That is the cluster that you're actually running, right? It's not the stuff that's running on it. It's what's running the cluster. That's what I'm going to call the infrastructure layer. There's the build layer. That's what the developers are going to deal with. That's the stuff they were talking about in the previous session. Building the application, the container images, the code that deploys all of that, and getting that stuff ready to go out into the cluster. And then there's the stuff that's the runtime. As I'm deploying, right, as I put that container that I just built, that image, as I put that container into my cluster, that starts the runtime and everything after that. I do a lot of DevSecOps, and it's quite often that people forget that DevSecOps doesn't end with release, right? That's really the beginning. The easy parts are before release. Everything else, most of the life cycle of an application is after it's in production, right? So that's the runtime. And that's the policies that you want to meet, whether because of security, because of governance, because of compliance rules. There's the resources you're dealing with, the network you're dealing with, and dealing with I'm going to say the system calls and interactions, the host that's running on, how your image interacts with those. One thing to keep in mind, I'm going to talk about security a lot as the same as quality. To me, they're interchangeable, right? You can't be completely secure without having high quality. You can't be completely secure anyway, but you have to have high quality to be secure, and you can't be low quality and consider yourself secure, right? There's just no way to do it. Too much of it's intertwined. Security is, in theory, the idea behind confidentiality, integrity, and authorization, and availability, sorry, thank you. CIA, right? And availability is the big one because it plays into everything you do, in that if you have a system that crashes, right? Just not a security problem or anything else that you'd normally think of it. It just, the application dies. Well, now it's not available. It doesn't matter whether your developers took it down by making a programming bug or a hacker took it down by getting in and doing a denial of service attack, right? It's down, right? The effect looks the same. So, all right. So let's start with the infrastructure, right? A Kubernetes cluster consists of servers acting as the master nodes and worker nodes. How many people have used Kubernetes before? Everyone? Good. Okay, excellent. So the cluster, the servers that the cluster is running on, they have to be secure just like any other hardware that you have, right? You're going to need to apply whatever rules you normally apply to them if they're running within your organization. Your ops usually has some sort of set of rules of here are the agents that we put on it, here's how we harden it, here's how we lock it down. If we work like I do in the federal government, there's something called the STIG, the Security Technical Implementation Guidelines, which is a list of best practices or recommended practices that you're supposed to meet to make sure that you've done everything you can to lock it down and make it as hardened as possible. These are the types of things that are usually done by an ops groups in a traditional, 5 years ago working with VMs, or even before that working with hardware. One of the things that's really important in trying to keep everything secure at this level is the idea of YAGMI. You ain't going to need it, right? It's the theory of least privilege, or the principle of least privilege, keeping everything off the systems that you're not going to use and making sure you're not adding stuff just in case you need it later, right? If you need it later, add it later. But the less you have on a system, the fewer things that are there, you reduced your attack surface, it's easier to deal with. And chances are, if you start building in a lot of complexity, a lot of additional features that you're not using now, you'll find that your situation has changed and you're not going to need it by the time the system needs to get replaced anyway, right? So one of the keys to the infrastructure is just going to be something simple, has nothing to do with Kubernetes itself, but that is keep your systems up to date. Update them regularly, replace them regularly. How many people here know what immutable infrastructure is? Okay, most of you. Immutable infrastructure is the idea that you don't go ahead and patch stuff, you try to replace it with newer, right? Just replace it outright. It means that things always stay fresh. It also means there tends not to be a lot of crud left behind from previous installations. It gives you a chance to upgrade. The act of trying to get to immutable infrastructure usually means a lot more automation, and it's a lot easier to replace things, which encourages you to do those updates much more frequently. All right, so that alone is a good thing. All right. Ronald Reagan had a famous quote that was, he said, the 9 most terrifying words in the English language are, I'm from the government and I'm here to help. In this case, these are some publications, the top 2 are publications that the government does put out that are actually quite good. They're not exactly light reading or fun reading. But I should mention, all the tools I go through, plus these, I have a page at the end with the links and everything. So if you're just looking to take pictures to get the links, there's one at the end, save yourself some trouble. Anyway, the Kubernetes hardening guidance is a paper put out by the National Security Agency and CISA, the Cybersecurity and Infrastructure Security Agency. It's not easy to read, but if you Google Kubernetes hardening guidance, there's a Kubernetes.io article that comes up that explains it in English first. Then you can go in and look through it. It's got good information in there. It's not impossible to decipher or anything like that, and it's not 1,000 pages long. It's fairly usable. I wouldn't say readable. It's not a novel. It's a set of guidelines, but it's worth going through. There's also the Kubernetes Security Technical Implementation Guide, which is the STIG I mentioned earlier. That is impossible to read. It's also impossible to meet. It's a set of recommended practices. They're great practices, but they're at odds with each other. You can't meet the whole thing. The whole point is you're supposed to pick and choose the ones that apply and ignore the ones that don't, but explain why you're ignoring them, right? As long as you've taken the explicit action of, hey, we're not going to use this control, you're supposed to be able to go forward with it. And your organizations may have different rules. It's intended for the government agencies. It is just recommended practices. They're good ideas for everyone. But as an example, not for the Kubernetes STIG, but for other STIGs, one of the STIG items is you shall not install a web server, right? Well, that doesn't make any sense if you're running a web server, right? Then there's a whole set in that same document of rules to say, if you install a web server, here's how you should install it. Here's some things you should do when you're configuring it to make sure it's as secure as possible, right? So that's what I mean when I say you can't follow the whole thing. Anyway, again, if you Google Kubernetes Security Technical Implementation Guide, there is a page that's called stigviewer.com. You can go to that, and it lists out, you can page through one by one each of the controls, each of the recommendations, much, much more digestible, still kind of long. The best of them in this is the CIS Kubernetes benchmark. It is CIS, it's the Center for Internet Security. It's a non-government, nonprofit organization. They put out a whole set of these benchmarks, they call them, that are just checklists of things you should do on your systems. They have them for Kubernetes, they have them for AWS EKS, they have them for Microsoft AKS, they have one for GKE, right? Whatever system you're using, they probably have one out there, and you can just go through and walk down the checklist of these are the things I should be doing to make sure I lock down my system as well as possible. Now, even better than that is we can run a tool that will do that same thing for us. Aqua Security has a tool out there called KubeBench. The question it's answering is my Kubernetes cluster installed and configured properly? Have I done anything stupid? Have I opened up something too much? Have I forgotten to lock something down? It applies the CIS benchmarks, and they try to stay in sync with the CIS Kubernetes benchmarks as much as possible. There is one thing about running a Kubernetes cluster, if you're not hosting the whole thing yourself, you're running on EKS, AKS, GKE, is that you don't control the master nodes. And in those cases, KubeBench will not check those because it doesn't have access to them. In the government, we talk about that being outside our security boundary. Basically, it's not my problem, somebody else's problem. They're taking care of it, they're worrying about it. And they've done documentation with the federal government to say, we actually can show that we've taken care of all of that. So you can just run KubeBench. It'll apply at least to the worker nodes. If you're hosting your own, it'll apply to both. And it just goes through a list of all the things that you can find. Let's see if I can, we'll take a chance here. And it is not going to show it there. Nope. I was debating whether or not I was going to try to do this, do some of these live, but it looks like it's going to be harder to do. Anybody that wants to see any of these, I'm happy to sit around and show you some of the outputs and run through them. But it's a little bit hard to do here just with I don't have a mouse, I don't have room for it, and I'm screwing up the screen. So, but basically, the KubeBench downloads, runs as a job in your Kubernetes cluster. You let it run, it only takes a few seconds, and at the very end, it spits out a text report right into the kubectl logs. Just kubectl log for the pod that it ran as, and you start seeing a list of everything that passed, everything that didn't pass. In this case, if we look closely, there's one here that's warned, right? Ensure that the event record QPS argument is set to a level. It goes on and on. It actually spits a little bit more out about that in the full output and basically says, hey, I checked, I couldn't find any idea what this was set for. If you were to run this on EKS, stood up with EKS CTL, that would be the only thing it would find. And it turns out when you look through the details it has there, sure enough, that setting is right by default. It just couldn't tell, right? But this is a really good way to run something through and just say, hey, was there anything in here that I need to do? Anything I should do to clean this up? On the cluster itself. There's nothing running on this yet, just the cluster. All right. Like I said, it only takes a few seconds to run and put in. You can run it over and over, although there's really very little reason until you replace the worker nodes. Okay. The build layer. This is where most of the stuff is going to happen. All right. These tasks are typically the ones that would fall to the development team, to the developers on the team who are producing their software. All of this is going to be a completely moot point if your code is security Swiss cheese, right? If you're just writing code that crashes all the time, that doesn't check any of your inputs, doesn't clean up any of your outputs, don't worry about the Kubernetes stuff. Get back and fix your code, right? That said, I'm not going to talk about any of that. There's plenty of ways to clean up your code and use good coding practice to write it as secure as possible. There are tools, though, that will check the code that you're using to deploy with. right? One of the tools I really like is called Checkoff by a company called Bridge Crew. It will check infrastructure as code, right? Any code that you're writing to do deploys, whether they're Docker files, Kubernetes manifests. We use it extensively for Terraform code. And it just goes through and says, hey, are there best practices you're not meeting? Are you opening up security groups that are completely wide open to the world? Are you forgetting to use the newer versions of some of these tools? Are you, just anything it can think of, it'll throw back at you. Huge list of things that it can and can't do. It really focuses on the principle of least privilege, right? How much can I lock this down so that if I don't need a permission, I don't have it. If I don't need a capability, I don't have it. Keep everything as simple as possible. That makes it easier to secure. Checkoff updates very, very frequently. I run it as a Docker container, and we just have it in our pipeline and literally do a Docker pull every time because it literally is sometimes more than once a day that it updates and can output. Bridge Crew does have an add-on. If you sign up for a free account with them, you can put in a code, and that gives you more information on the output and does a couple extra checks. But really the big thing is it gives you links to the findings it has so that you don't need to Google them yourself. So when that runs, this is also very, very quick. I just ran this. Anybody familiar with the Weaveworks sock shop? You may notice some of these names. This is just running against Kubernetes manifests, and I've set it to be quiet, which means I only want to see the failures. Don't tell me all the things that pass. There are literally hundreds of checks it does. So while it's great if you're trying to do an audit or something like that to show all the things that you did right, if you're a developer and trying to clean stuff up, what you're really focused on is what did we do wrong, right? And so if you see here, you'll see some of the outputs where it just tells you what failed, what the rule is. It has a checkoff code there, a little ID that you can Google for on, or you just look up on Bridge Crew's site, and it gives you here's what a bad one looks like, here's what a good one looks like, here's what the risk is for not doing it. Very easy to use, and like I said, it works for all different types of infrastructure as code. About the only type of code that we use at all that does not go through checkoff is Ansible code. We use Ansible lint for that instead, but everything else gets checked with checkoff. Very easy. And this is actually fairly easy to get everything looking clean on. Every now and then we have some suggestion it makes that we can't abide by, and there's an easy way to tag. Just put a comment in the code that says, hey, I'm explicitly skipping this one because you put a note in there for yourself. It comes up, it doesn't show that it failed, but it does show that it was skipped and has your note spit back out at you. So you're being explicit about it. You're not getting caught with, hey, I turned this off and I forgot to turn it back on when that situation wasn't true anymore. So very easy to run against an entire directory. It's very easy to run against individual files. Again, runs in mere seconds, throws it out. There are plenty of other tools out there that will do this as well. Like I said, we use the Terraform a whole lot, so we stuck with it for this. But Kix is another one. Trivy will do it, which I'll describe in a few minutes. A lot of other good tools out there. Any questions up till now? All right. Next one, Trivy. Once you've built a container image, you have a certain amount of code running on there. Now, the goal would be to have as little running or as little installed on that image as possible. All right, if you're writing statically compiled code, it's great to deploy onto a base image that's Scratch, right? There's literally nothing else there. It's just that piece of code. But for a lot of the stuff we write, we need some supporting libraries, some supporting utilities that run on the system, some extra files maybe from the file system like the Etsy password type stuff so it can use users. For those, there are ways to check to see is everything that's on there safe, especially if there's other packages. And vulnerability container image scanning is really looking through the list of what's installed on the system and tell me, do any of those things match up with known CVEs, right? Do I know there's a bug in this? Log4j is the classic example nowadays. Do I see Log4j on the system, right? Or I guess after yesterday, do I see that particular version of OpenSSL on the system, right, that I might be able to upgrade? Trivy can be used in two modes. The first is I can go ahead and I can scan the infrastructure's code, the Kubernetes manifests, to see what goes on it. Spits out the same types of information. There's a huge overlap, well, almost 100% with checkoff in this case. If you're looking for just one tool, Trivy might be the one to do it if you're not doing Terraform like I am. And when it runs, the first thing it does is downloads the latest rules and updates the database, and then it goes in and checks your code against that and reports back anything that it finds, right? For instance, in this one, it's finding the container. We're searching carts in SockWorks or in the Sock shop. It should set security context dot allow privilege escalation to false. It's not done in that particular manifest, so it throws back, here's the manifest we found it in, here's a link to how to fix it, go ahead and set it, right? Now that's doing a config check. The other one is the image check, and this is actually doing the container image scanning, where it's going to go look through, it's going to download a list of the latest CVEs as of today or as of this hour, and it's going to look through all the things that are installed on that system and tell me, do any of them match CVEs that are open, right? Generally, what that means is, are there packages on this that I should update, right? And if barring that, there may be mitigations I have to take to make sure I'm not using those features. I'm not doing that type of thing on the system so that this doesn't affect me, or putting web application firewall rules in place to keep that from happening. And the best overall fix is, can I go to a different type of base image that doesn't have this installed because I don't need it? Can I go to something smaller? How many of you are creating stuff with Ubuntu base images now? Right, a few. What types of images do you use when you're creating containers? UBI from Red Hat, good choice. I'll talk about it in a second. Alpine. So those are great examples. Alpine is a really small version of Linux, right? So it has less installed, so it's a smaller footprint. There's less to protect, right? It still is an OS, and there's still stuff there. UBIs are even bigger. They're actually Red Hat installations. The UBI minimal is as small as you can get and still have a running Red Hat system, and they've done everything they can on that system to lock it down as tight as possible, but you have Red Hat available to you on that image. So if you can get it smaller than those, there's systems out there called, by ChainGuard called distroless, which they've removed everything, including the kernel, that they can, because you're not really using the images kernel, you're using the kernel on the system, so it's even a little bit smaller. There's Google Container Tools, I think is the link in GitHub, has distroless that's a little bit bigger than that. ChainGuard's claim is that they're going to have these things updated daily, so it always has the latest patches. Google's is a little bit slower than that, but not slow. So the idea behind all of those is update frequently, keep redeploying. You ain't gonna need it, so don't put more OS on the system than you have to. But if you do have to, do the image scanning, find out what needs to be updated, and try to update it or try to go to the latest base image to get those. All right. One other thing about image scanning, we'll talk about doing it at build time right here. The developer creates the image before they go ahead and push it up to Artifactory or push it up to Nexus Repo or to your Docker Hub or Harbor or wherever you're pushing your images. You just scan it, make sure it's good, right? The scanning can't stop there, because what was considered safe yesterday or wasn't known to be vulnerable yesterday may be vulnerable today, right? Again, just because it happened yesterday or the last couple of days, OpenSSL, if you scanned it last week, everything was great. You scanned it today, those things might not be true. It's not that it's less secure today, but the fact of the matter is people know about that hole today, so it's time to fix it. We know there's a way to go. All right, so you need to keep scanning. You can scan these things in while they're out in the cluster. You can scan things when they're in your image repository, your registry, and I'll talk about one other thing to do in just a minute. But it is an ongoing thing. As long as you use that base image or that full image, you need to keep scanning regularly to look for known vulnerabilities. Okay. Trivy does a really, really good job. I have nothing against Trivy, but there are some things that it just doesn't seem to find. And because of that, and other people have found the same thing, because of that, we also use a tool by Anchor called Gripe. It works the same way. It does the same types of things. And there's a huge amount of overlap. I'd say probably 95% overlap between what it finds. But that 5% for us, for the extra couple seconds it takes to run both of them, is worth running it twice, right? So we run Trivy, then we run Gripe, and we look at both of them. Chances are almost everything on there will be found on both. One of the nice things about the Gripe output is that you see this column here where it says fixed in. It tells you if there's a new version out there that fixes it. Quite often it will say won't fix on older images. And what that means is the vendor, whoever the vendor is on the UBI, would be Red Hat, has said, hey, we are not fixing that. It's either not a problem, it's not, there's other mitigating reasons that we don't care about it, or frankly, we've just moved on. So for instance, if you use the UBI for RHEL 7, a lot of those things are won't fix because they just say, hey, just upgrade to RHEL 9, and then you don't have to worry about it. Use the UBIs for 9 or for 8, right? Okay. Anchor Trivy, yes, it should be Anchor Gripe. Thank you very much. Yes, cut and paste there. It is Anchor Gripe, yes. All right. One of the other things that I like about Gripe is it will work with another Anchor tool called Anchor Sift, right? We heard a talk yesterday morning, I think in one of the keynotes, they were talking about SBOMs, the software bill of materials. And it's a list of ingredients, all the stuff that went on to, in this case, your image. Plus, if you're running, let's say it's a Java application, all the components that went into your Java app, all the libraries that are brought in, frameworks, components, that type of thing, right? President Biden released it's Executive Order 14028, and I'm blanking on what the name was, something about improving improving the nation's cybersecurity. And one of the things that came out of one of the few really, really, really actionable things that came out of it was said, if you're selling to the government or if you're in the government buying from someone else, you should be getting an SBOM with the software, a list of ingredients. The nice thing about that is that list of ingredients stays fixed as long as you keep the same image, right? So every image, in our case, produce a new SBOM. SIFT will do it really, really quickly. There's all different formats it can go in. SIFT has one that's native to it that works with Gripe really, really well, but there's also a format out there called Cyclone DX that's rapidly becoming one of the de facto methods for writing out or formats for writing out SBOMs that can feed into other tools. And if you keep around your SBOMs and put them in a repository somewhere that's searchable, when something like OpenSSL comes out or Log4j comes out, you can go ahead and say, hey, what applications are using that tool so I can go back and fix them later, right? When you're building, it's easy to scan and say, I have this or I don't have this. As part of an enterprise, part of an organization, it's a lot harder after the fact to say who is using this, right? That was Equifax's problem a number of years back with the struts code. They had a vulnerability in an old version of struts. They didn't even know what applications they had out there that were using struts, and they didn't have any good way of finding other than to log on to systems and actually do a search for it, right? Which is not the optimal way to do it. So here at the top, right, you see the command to run SIFT. I just run it against an image, give it the output format as JSON, spit it out to a file, and then I can take that file and hand that file to Gripe, and now Gripe can scan it. Now I can keep that SBOM around, or I can keep a whole directory full of SBOMs and just run Gripe against it all the time, look for new hits, right? Or I can use SIFT, as you see at the bottom, which is in the Cyclone DX JSON format, And for that, we can use a tool called OWASP Dependency Track. And OWASP Dependency Track will also do some of this interpreting SBOMs, but one of the big things it can do is you can just constantly feed your SBOMs to it, and then it becomes a searchable database of those SBOMs. It can handle notifications. It will automatically download the vulnerability databases every day, run it against its catalog of SBOMs that are out there, and notify the team that submitted that SBOM that, hey, we found something new, right? It's a management system for that. It will do the identifying the vulnerabilities and everything as well, but its key is really that I feed it the SBOMs. It can give me a view for the team to go in and see, do we have anything new? And it can provide a view for the organization to say, here are all the things, here are all the systems that are using this particular problem, or this particular vulnerable component. It is a system that gets set up. It's a server you have to maintain. It runs in Docker, Docker Compose, Kubernetes. Fairly simple to install and set up. And yeah, just a nice interface on it, easy to see some roll-ups of things, and easy to handle. So the key with all of this, with all the image scanning, is it's not a one-time thing. This is something that has to be repeated over time. If you're dealing with the federal government, you're going to have to produce SBOMs anyway. You may as well stick with them and throw them into a repository and let them help you do your work. So even if you're not dealing with federal government, it's still a good idea. All right. Any questions on any of that? Yes? Stick it in this in dependency track, and it will do the scanning for you. Okay. And the nice thing. You can feed that SBOM into Gripe. The thing is, like, Gripe is really set up to do image scans, right? So it's really focused on. It'll find vulnerabilities in an OS. It's hard to get a SBOM for a plain OS, but it can be done. SIFT can actually do it. But you'd also want your SBOM for your Java app, for your Python apps, for all those other tools. Dependency Track can handle all of those SBOMs. So you're not just relying on just something like Gripe that's really focused on the image scanning. So you can put it wherever you store it, whatever, and check out the check out. We just put Dependency Track running in our tools network, and as part of everyone's pipeline, we tell them, hey, just put this. It's just a curl put. As soon as you build your SBOM, send it up. We have examples for if you're building a container, you're going to use SIFT, and here's how you send that up to Dependency Track. If you're building with Maven, there's a Maven library that will build a Cyclone DX JSON file that we can also send up. And right, we go through each of the tools. Cyclone DX has a really, really great site out there for all the different tools. And it will just, for any language basically you're using, it uses the dependency system to figure out what goes into it. You upload the SBOM into Dependency Track, and then you can start getting the notifications no matter where the SBOM came from. Yeah, the question was, there's an API for clarification. There's an API to Dependency Track to submit everything in, yes, and there's outgoing APIs for setting webhooks, for writing out to Splunk, for sending out notifications. It can send out emails. It can send it out to a SIEM, however you want your notifications to come. In fact, I think it can even write to Slack or something like that too, if you wanted. All right. Okay. So that's the build. So we did the infrastructure, we did the build. Now comes the runtime. This is what was traditionally the ops piece of DevSecOps, right? The operations group was handling it. Again, in DevSecOps, it's not done when you deploy it. It's just a new phase for it. Got to keep monitoring. Got to keep watching things. Don't forget about the basics. It is truly embarrassing to see how many operations organizations with multi-million-dollar budgets, tools all over the place, 24/7 monitoring, let a system get taken down because it ran out of disk space, right? Something so easy to monitor, so easy to track. They already have the tools there. They're just not doing any alerting on it. Don't forget about the simple stuff, because the simple stuff's usually the problem. But anyway, here are some of the things we can do with Kubernetes. First is policy enforcement. There's a tool out there called Open Policy Agent, or OPA, that lets you set up rules to say, hey, I should or I should not let the resources or workloads into my system, into my cluster, that don't meet these rules, right? One of them is, say, a lot of people like going with latest, and they talked about this in the last one. You know, I want to use the latest of this image and deploy that to my cluster. Well, that has some problems because you don't know what's going to happen when someone comes out with the new latest. Will it still work with all your other systems, right? So there's an issue. You could argue that, hey, we always just want the latest and greatest, but you are taking a risk that they've done something that's no longer compatible with the way you were using it. A lot of people like to stick with tags, right? So I want to use version 1.0.0, right? And I'll just always pull that one. That should be safe, right? Except the tag is just a pointer to a version, and people can move that version. Just like latest is just a pointer to a version, and it moves, right? So there's nothing that guarantees that what 1.0.0 was pointing to today is the same thing it's going to be pointing to tomorrow or next week. Usually that's not an attack. It's just somebody changing. They've released a new version, right? It's usually not, it wouldn't be semantic versioning type things. But if you're doing it, if you want to be truly secure and know, hey, we 100% sure we have tested with this particular image, you can use the SHA-256 of the digest of that image, right? And if you use the digest of that image, you can make that a policy, and you can tell OPA, or actually OPA gatekeeper, to say, hey, I'm not going to let any images deploy into this cluster or into this namespace unless they have a SHA-256 attached, so I know exactly which image they intended to deploy. It can never change, right? In theory, that SHA-256 is unique, and it's not used by any other images. And it's actually fairly easy. There's a whole site out there of, it's called OPA Gatekeeper. There's a whole site of policies. It's a library that you can just pick and choose from, pre-written. You can go ahead and customize it. Basically, you set up a template for it that they provide, and then you go in, after you deploy that template, you say, hey, this namespace is going to use that template. In this case, the one I was just describing, you know, if I was to install that one and say, hey, we require SHA-256 digest on all our images, this one would be let in as soon as I go to deploy it. And then if I had something like this where it's not, it's just using a semantic version, 0.92, it would say, can't do it. My admission webhook, the OPA's webhook or OPA Gatekeeper's webhook is saying, you've set up a rule that prohibits that from going in. And there's all different rules you can set up to allow it. Things that don't have memory limits set, things that do have memory limits set, however you want to configure it. There's all sorts of rules you can put into place. Basically, all those things that Checkoff or Trivi's config scan were doing, you can enforce through OPA to say, hey, I know we've told the developers to scan and fix all this stuff, but I'm actually going to enforce it by saying you can't deploy if you don't meet all those rules. And there's ways to allow exceptions in and different namespaces and stuff like that. It's becoming very, very popular. It uses a language called Rego that is fairly extensible. It doesn't have to be, policies in OPA don't have to have anything to do with Kubernetes. It's just a popular place it's getting used. All right. Another tool that I found really useful is Fairwind's Goldilocks. And that checks to see, hey, are a few containers using all the memory, all the CPU in my cluster that my worker nodes have available? You're supposed to, if you're following all the best practices, set limits or set requests for how much memory is this container going to use, how much CPU can this use, right? There are pedantic arguments about whether or not you should put limits on it, or whether just what you request, but it has to do with how much scheduling the Kubernetes scheduler can do, how much advice you want to give it, and what you want to happen if something starts running away and asking for too much. It's very much a Vim versus Emacs type argument, so it's not anything anybody's going to win, but depending on what rules you want to put in place, you do want to put something that's checking these and making recommendations. Generally, as developers, when we deploy a container, we don't have any idea how much memory or CPU it's actually going to use, especially once it's under load. Goldilocks works with a system called the vertical pod autoscaler to watch what the system's using and just make those recommendations for you and actually spit out the YAML that you can stick into the manifest to show what it should be using. So the best way to use it, go ahead and deploy some stuff, run it under some sort of load, whatever you think is representative. Then all you have to do is tag the namespace with the right label to say, Goldilocks, please watch this for me. And then you can go in, they have a website in your cluster that you can go to and just download and say, hey, if I want to guarantee that I have this available, what should my settings be? Here's what I would use. This is a good setting for it, that type of thing, right? It's just there to give suggestions. It's not infallible. You have to run it under load, or else it's telling you, what the unloaded system does, and that may not be representative of what you really need. All right, almost done here. Network isolation. If you've been to any of the talks on Istio or any of the other service meshes, one of the things that's important to do in a Kubernetes cluster is not just trust the perimeter security, not make sure that people can't get into the cluster. There might be a bad actor inside your cluster, and it may just be because it's someone who's misbehaving. It may be somebody who gets hacked, another team that gets hacked, and now the hacker is inside your cluster. One nice thing to do is make sure that, hey, this pod can talk to this pod, but no one else, right? Put down some lockdowns on that. Kubernetes has tools to do it. Service meshes will do it, but if you're not using a service mesh, you should use the container network interfaces to do it. There is a site out there called networkpolicy.io, and you literally draw how all the things are going to happen, how you want the system to work, who you want talking to who, and it just spits out the manifest for you so that you can plug them in. Or like I said, just use a service mesh, and that usually takes care of it with labels. And the last tool I want to show is Falco, and it's looking at the system calls that your containers are making, and just watches, are any of them doing something weird? Do you have a container that's looking for Etsy password or Etsy shadow? Do you have a container that's trying to open up a new network port that wasn't originally there, that wasn't originally exposed, right? Are you changing, doing chmod or chown on a system, right? Things that system calls is making to the underlying system that may indicate that something funny is going on. And all a Falco does is you just plug it into your Kubernetes cluster or put it onto your worker node, and it runs and just has logs. It can spit out to Prometheus or pretty much anything else and just says, hey, I saw something funny happening here. You can set up policies so it can actually block it from happening, but most of the time what you're looking for is, hey, just something weird just started happening. Let's go ahead and start doing some research. All right, quick wrap up here. Key takeaways. Absolutely enforce the principle of least privilege. Make sure you don't give privileges you don't need. Keep everything up to date. That's the number one thing you can do to avoid using systems with vulnerabilities. Scan your container images frequently before and after deployment. Monitor your systems for expected and unexpected behavior and disk space. This is the tools I mentioned about reading. These, if you Google them, they're a little bit easier to find than just trying to type these very long URLs. I'll give you a chance to get them. Everyone. And then this is a list of all those tools I mentioned. Like I said, all of these are open source. There are commercial versions of almost all of these out there, or there's a commercial offering that has this tool built into it. So if you like the tools, it's worth supporting the commercial companies that actually release the stuff open source, and it may give you features that your organization wants. And that is it.